Alright, hello, welcome back to A Software Engineer Plays, the YouTube channel where a software engineer plays through games designed to teach you aspects of programming, logic, problem solving, all that good stuff. We're back in TIS-100 today. We're going to take a look at the signal multiplexer segment, and let's jump right in. Okay, so we're supposed to read values in from A and B, and then read a value in from S. Write in A, okay, when S is -1, and in B when S is 1, and A plus B when S is 0. Okay, so it seems to me like we need to, first of all, let's move all of these down into the accumulator. And now let's open up our user manual. So I think we're gonna have to use the jump jump equals, jump less than, and jump greater than 0 commands. But the question, let's figure this out. We know that we have to store something in the accumulator so that our jumps will work. So, okay, if it is 0, okay, so move accumulator to the right, and move accumulator to the left. Alright, so just setting up my jump statements here. I think we're going to want to have a start label at the top as well. So do 0. For 0, we want to move left into the accumulator, add right, and then jump end. I don't know if we're gonna have enough space here for this, but we'll find out. Do 1. Jasper, can you stop? I have a very needy cat at my feet here, so if you can hear her meowing on the video, then that's what's going on there. Alright, if S is 1, write in dot B, so we will move right into the accumulator, and then we'll jump to the end, and then do -1, move left into the accumulator, and we're out of space. So this is a problem. But instead of jumping to the end, I guess what we... No, because we want to move down. So this is not going to work here. I guess instead what we could do, instead of doing all the logic here, let's try this. Let's move up into the accumulator, and then we will move the accumulator left and move the accumulator right. So move up to the accumulator, that's fine. Okay, so now we want to swap, I believe, or do a save rather. So that'll move the accumulator into the BAK register. And then we want to move left into the accumulator, move right into the accumulator. Okay, so now we can, if the accumulator is, let's see, if it's A, we want to do a -1. So, or if it's -1, we want to do 0. So jump less than 0, out, -1. All right, and then we'll jump start. If, however, it is a 0, then okay. So if it's 0, we want to swap the accumulator and the BAK, and then we want to move accumulator to the right, and then we want to jump start. Okay, so how I'm thinking this will work, we'll get the value of S over here. S will then be moved into the, well, let's step through and see it if we can see it work here. So 13 comes in, we're going to save that to the BAK. Then -1 comes in, we store that in the accumulator. Except I have my directions mixed up. That needs to be moved right into the accumulator. Okay. So -13 comes in, -1 comes across. Now, because it's -1, it is less than 0, so we should output, not a -1, but we should output our, I think we output our accumulator after we do our swap. Okay. Yeah, okay, so that will output a 13, which we can then move down and out. Move up to the right. Move left, down, move up, down, move right, down, move up, down. Okay, so there's a lot going on here, but we want to copy this here, move left into the accumulator. Instead of -1 here, we want to handle +1. Handle 0, that's fine. Out +1, that's fine. Move up to the left. Okay, So this should, when we get to 0 here, it should work for all of these. Let's find out. Okay, we get a -1 in, so we should output in.a. And we do. Now we get a regular 1 in. We should be outputting a 7. I see a problem. Okay, so the problem here is, as you can see, we end up getting stuck here where we can't actually, since there's nothing coming up from up, we get stuck. So let's stop there and rethink here. Clearly, we know that we have to make use of all of these blocks here because we only have the one accumulator. It's not like we can store A and B and S all in one bank here. So what else can we do? That's an interesting thought. So I'm thinking now, if we let's give that a shot. Okay, so I'm thinking if we take the value of S in here, and if it is -1, we'll output the value in the accumulator. If it's 1, we'll output a 0, and otherwise. So the only thing we would need to handle there is we'd need 2 cases. If it is less than or equal to 0, we output the value of in.a in the accumulator, otherwise we output 0. Let's give that a shot. And then we'll add those values together down here and output it. So this will be doing the addition, and let's give that a shot. Okay, so we do need that's all fine. And then we do need, okay, so less than 0 and equal to 0, we want to output the accumulator. Otherwise, we output the move a 0 down, and then out accumulator, move accumulator down, jumpstart. Okay, good. So the way this should work, Downton Abbey. Alrighty, start, move up, move left into the accumulator. So you see what we're doing here is basically hard coding a 0 when we do not want to output the value of the accumulator, so that here we can just add together the values coming in. So we'll move left into the accumulator, we'll add right, and then we'll move the accumulator down. So let's see how this works. We get a 1 coming, -1 coming in. So that gets stored either side. We're going to process through. So because it's a -1, this is outputting a 0. And, ooh, that's outputting a 0 too. Okay. Why did that happen? I suspect... Oh, we're not doing any swaps. So here's the problem now. We are not doing any swapping. We need to swap when we do this. Alrighty. Stepping through now, negative 13 comes in, so now you see we've got it saved here, so we need to do the swap instead of outputting a negative 1. There goes the negative 13. There comes the 0, we add it together, we move the negative 13 down, and we output the negative 13. So now we should have a 7 coming down. There it is in the accumulator, moving the accumulator down, moving it across. And now we have to wait to get our 0. And there we go. So this is working. Let's just run through it here and see how we're doing in terms of speed and cycles. 309 cycles doesn't feel too bad at the outset, but we will see. 309, 308, 313. Okay, so 313 cycles versus the 275 that my other friend was able to achieve with 5 nodes and 18 instructions. So, clearly we can do this in such a way that we do not need these additional nodes. And maybe if instead let's see here. How can we do this with just these nodes? Well, I guess that's a pretty, it might work. Let's give this a shot here. Move up into the accumulator. Or actually, let's move up left, right. Move up right. And this one will move up left. Okay. Into the accumulator. Jump less than 0 to out A. Jump greater than 0 to out B. Jump equal 0 to out both. Okay, so now we may run into some problems where we don't actually use what's hanging out in the incoming I/O, but let's see if we can figure out how to deal with that. So, if we are less than 0, we want to move A, which is the left, down, and then we want to jump to start. And let's out B, move right, down, out, jump start. Okay, jump start. Give it a jump start. And now we want to move out both. Move left into the accumulator, add right, move accumulator down. So, my concern here is that if we get to, well, like this first example here, we're supposed to output negative 13. So negative 13 is going to come in, but we've got this 7 hanging out here, so I don't think that 7 is going to go away ever. Let's see. Yeah, so the 7 is still hanging out there, which is a problem, because now we're outputting 7 again. So, okay, new plan. We are going to start by sending the value of S to both the left and the right. Move accumulator left, move accumulator right. Now we do our save and we move left, move right into the accumulator. So basically what we're going to do now is we're going to send the values, like how we did it before, we're sending the values back to this node instead of down and then down. So we're going to use a few fewer nodes here, and hope for the best. If in jump less than 0 and send accumulator, jump equals 0, send accumulator, otherwise move 0 right, and then jump start. Send accumulator, move accumulator right. Start, okay. And colon, good. So we're just gonna copy all of this, change all these to be left. Good. And then we will move left into the accumulator, add right, and then move accumulator down. We'll put a comma after accumulator because the game needs that. Okay, so how this should work, we will get a -1 in. We'll send that to both sides. But we got problems. Start, we want to move up to the accumulator, not to right. Alrighty, step in, move it to the accumulator. We got our -1. So now we're doing stuff. -1, it's less than 0. Oh, we need to do our swap. Okay. Stepping through, -1 comes in. We send a 13 or a -13 across, and I notice that I have my incorrect. This needs to be a G here. Jump greater than 0. Okay, there we go. So now, we got our -13 in, we send it, and we should move a 0 across there. There's our 0. Send it across. We've added them, we're sending it down, and out it goes. Keep on running. Seems to be working just a-okay. Cycles, it's a lot slower than the previous solution, but we are doing it in fewer blocks and fewer instructions, so I guess that's a plus. What other... Okay, we do have a jump not 0, but that does that help us? Not really. 18 instructions. We can read this debug story here. I might have an idea of where this TIS-100 machine came from. Described the architecture to Fred at Motorola, and he says it sounds like it was designed for signal processing. That got my brain going. Government project, maybe. Something like, oh, the CIA cooked up to comb through Soviet radio signals. Hush hush, top secret. Classified device. Interesting. Uncovering the story. Okay, how do we get this to go faster? Clearly we need to do something based on the value of s. We need to have branches. And we need to read in A and B either way. We did try getting both A and B in here. I guess we might be able to do it with swapping. Maybe. Let's give that a shot. This is just gonna move up right with a comma because it doesn't need the comma. It doesn't. Oh, that's nice. What else? I mean, are there any? I just had an interesting thought. I don't think it's anything. I was thinking if we could do something mathematical to the value of s, so that no, it doesn't. It doesn't make any difference. If we could adding values to s here so that we don't have any negatives doesn't really help me out at all. We have the JRO command, which jumps to a line. That's interesting. I don't know if it would help, but okay, so now we need to have our jump greater than 0. We'll just call it GZ, jump less than 0 to LZ, jump equal to 0 to EZ. Haha, easy. GZ, LZ, EZ. So, greater than 0. I mean, either we want to, it's kind of unfortunate that we have to do this based on the value of accumulator. It'd be nice if we could have a temporary variable, but greater than 0, we want to send B. So we will, we're not gonna have enough space though. Move left into the accumulator, move right into the accumulator. Are we though? Oh, that's an interesting concept. Move right into the accumulator, move left into the accumulator. So we're basically just going to overwrite the value of the accumulator. If it's equal to 0 though, we'll move right into the accumulator, move left, or add left. And then we're not going to have enough space. See, this is the problem. What else can we do? One of my friends was able to get this to execute in 275 cycles, so I have to be able to get this to execute in 275 cycles. This is the challenge. I mean, I guess we don't actually need the jump if equal to 0 statement there, because we can just put that there. We do then want to call this out ack. Okay, so then jump out ack, and here, okay, ooh, look at that, we have just enough space. So what we should get now, we get both numbers coming in. 13 and 7. Now we know that it is less than 0, so we're going to jump down to the less than 0. We're going to move the right side into the accumulator. Then we're going to move the left side into the accumulator, and then we're going to move the accumulator down. And then we continue as expected. And it seems to be working. I'm hoping that it's fast. No way to know for sure until we complete our tests. It does seem to be going faster than our first and our second solution, but not quite at the 275 cycle rate. 294. Okay. I did it in, 16 instructions, so I'm at the top of the list here. My other friend had it done in 18 instructions. So we need to shave off another 20 instructions somehow. Some people got this done at like 100 and close to 200 instructions. That's pretty crazy. But how? We do have all of these other instructions. We don't have to complete all challenges at once, so we can go crazy and just use all of these if we want to. Maybe that's something we could look at. I am scouring, because I think it should really be, if we can, if we can get rid of the value that's coming in, like if there's a way to just throw that away. And now that I'm reading the manual, I see that we can actually move values to this nil, meaning 0, null essentially. It's just discarded. So that is interesting. So like how we had it before, right? So it equals 0, we wanna, let's actually bring that back. That's all fine. Let me just see, we don't actually need these extra moves here because we can just, if it's greater than 0, we want to, greater than 0 means move left, no, yes, no, right. Move right down, and then move left to nil. And we don't need our accumulator there. Okay. Should really be consistent. Jump, start. Start. Move left, down, move right, nil. Jump start. I don't know if this is going to be any faster, but I'm interested to see what happens. So negative 13 comes in. So we move left, down, and we move right, nil. So that clears it out, so that's good. So let's run. It doesn't look like it's going much faster than the previous solutions, but we got 275 there, so that's cool. 271, okay. Cool, 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 cool. And 279, okay. Interesting, interesting. So that is a little bit faster, but not quite as fast as my friend. I wonder if there would be any way to do this in parallel. Meaning we get two values coming in and then two sets of values, so we could do two at once, basically. That sounds like a question for another day, so I will say thank you very much for watching. We'll come back and see if we can parallelize this and make it a little bit faster. And then see if we can solve any more problems. Anyway, this has been a Software Engineer Plays. Thanks again for watching. If you enjoyed the content, please like, comment, subscribe, ring the notification bell. You know what to do. Have a wonderful day. Go out there and solve some problems. And I will see you in the next video. All right, bye.